Next one coming up here is Marwa Dabayev. She's not only a great person and a brave soul, she's also a full professor in architecture, environmental architecture and urban sustainability. You're head of at the Malmö University. And you're also having a project now, the 3D and yeah, you're going to talk about that now. So, yeah, okay, thank you. Yeah, yeah.
Thanks to be here today. I don't need a mic, or I do need a mic.
Yes, yes.
Excellent. Thank you so much. Thank you for your interest and for being here today. I think it's a wonderful opportunity to not only to learn from each other, but also to join forces, I hope, from after the end of this wonderful day. Hopefully, we can continue doing even better change in this world that we live in. Today, or in this coming few minutes, I will talk to you about bio-based construction, but hopefully I will add a small, tiny perspective compared to the wonderful talks we had in the morning. So before I start, I want you to close your eyes, but if you don't feel comfortable, don't do that. So I want you to imagine a two-road journey from whatever two destinations, from home to work, from work to your countryside, summer house, whatever. One of them needs to be in a place where you are very close to nature. So you see trees around, maybe there is a lake or a water channel, a river. So you can see maybe reeds, or you can see farmland with a lot of agriculture, crops, where it could be a lot of bio-based straw as agriculture waste. And then another road where you might meet a mountain or a hill where there's a lot of stones, different colors, different shapes, different texture. And then later on you find a huge piece of land where there's a lot of clay, soil, also comes in different forms, different colors, different sizes, and different textures, and maybe different smells. And let's imagine a completely different road in a city. All what is around you is just concrete buildings. So actually the materials that you're going to see is mainly concrete, maybe steel, and some fired bricks. So now you can open your eyes very slowly. Let's face the reality. So those roads, are we really paving the way for more sustainable practice, or we actually lost the way in this road? So as our colleagues mentioned, actually somehow we are reinventing the wheel. And we, as Johan said, we are relearning the history. So wasn't that the default in all times? Vernacular architecture is all about using what is available around you. So what is this bio-based construction? As the famous Egyptian architect Hassan Fathi said, build with what is under your feet. So if it's soil, you build with earth construction. If it's stone, you build with stone. If it's wood around you in the forest, you build with wood, with reeds and many more. So there is a huge spectrum of varieties of material that's around us. And why nowadays we are kind of promoting for this kind of bio-based construction? Because again, we realize that we have lost our direction, we have lost our compass, and we really need to come back and understand the importance of using this bio-based material in order to reduce all the kind of mistakes that we have done before and kind of cope a little bit with this modern challenges. So the wide spectrum of bio-based material, as also our colleagues in the morning said, so I don't want to repeat again things, but they are starting from what we are familiar with and common material to use, which is wood, until the newly innovative one, which is mycelium. But there are plenty of key principles that we have to keep in mind. Like in old times, when they have a crop, they will use the shell after they eat let's say here the corn as an example. So they eat the seeds, and then the shell, they are not just peeling it and throwing it away. They will be using it to weave baskets and do some other nice handmade household things. And then the main stem, they will be using it actually as fuel, biofuel for their furnace to cook or to bake, or just also as food for animals. So nothing goes in waste. It's us who don't understand that this is a potential material to use. And then nowadays we are trying to feel very creative, to be like showing that we are very creative and innovative, and trying to find some possible products out of this kind of waste products. So again, the common ones is the wood, and then this kind of very trendy, innovative plant-based material. We use them for not only in the construction sector, but in many other products, and of course the agriculture waste composites. But we have to be aware that there's a huge greenwash in this process. So when we use wood, I was happy in the morning to hear that wood is not the best material in many parts of the world. Even our neighboring country, Denmark, and even in south part of Sweden, wood should be the big no-no to use. And if we just compare between these two a pen and a pencil, which one will be more sustainable, environmentally friendly, and low impact? This is a wood and graphite. Everything here is natural. Here is plastic and ink. Everything here is artificial. But really, which one has the lowest impact and more sustainable from life cycle perspective? Exactly. Why? Because the way we grow wood and we treat it, we transport it, is not sustainable by any means. We are still way behind in being able to use wood in the right way, if it is the right material to use in a specific location, in a specific part of the world. So we need to be aware of that. And we heard about the wonderful, good benefits of using bio-based material. So it's not only to kind of capture the carbon, but actually we could reach way beyond that, and we could reach actually minus carbon. So we could sit comfortably until we end our life as humans, that we will leave some offset for the coming generation. And this is what our ancestors used to do. It is just we destroyed our children possibilities, but our ancestors, when they left the legacy, they left really a good base for us to use, but we abused this important asset that they left for us. And of course, it is possible to reduce a lot of construction waste if we're able to use the bio-based material in a proper way, because it's easy to reuse, it's easy to biodegrade, and then we close the cycle, and we achieve the real meaning of circularity. But I want also to highlight, it's not only the material that we need to focus on. It's also the way we design and the way we implement the material, because we could achieve a very low energy consumption because we are using this natural bio-based material. But also when we don't do the right architecture design exercise, we can ruin actually the fact that we have been using a nice product from a natural material, and then we lost everything again. So we lost the good quality of the natural material, and also its purpose impact. And then, of course, we improve biodiversity and, of course, enhance air quality. It's actually a breathable material, like our body breathes. So that's why we always resonate when we live, or when we work, or when we visit at least a building that is constructed from natural and specifically bio-based material. But some people said, like, yeah, but all those old buildings that you try to claim that they were the best and they were like the idealistic way of construction, like this one, for example, but we are, even in winter, we are opening the window because it's too warm. Yes, because we sometimes like over-expect how the buildings should perform now compared to before, and also when we use them for different purposes. So this building wasn't supposed to host all this big number of people at the same time, right? It's not supposed to have all those big flashlights that produce a lot of heat, all those equipments and so on. So also we need to understand like how we can accommodate our modern needs at the same time that comply with what those kind of natural material could offer as well. But we are in a lucky situation because the technology is on our side. Definitely is on our side. All these kind of possibilities using 3D technology and prefabricated panels and systems and elements and modular systems is actually giving us a huge possibility to use those kind of material in the best way possible. But is it that easy and rosy? No, we have still a lot of challenges. Many challenges are ahead of us. And not to be pessimistic, but also to be a little bit realistic here. We need, of course, to ensure that the quality of this kind of material is possible to comply with our modern standards. And of course, to develop the standards and the codes and mandates that can allow us actually to use them. Otherwise, it will always stay business as usual. And of course, to balance the land use. Are we growing those material to use them, or they are the waste from existing agriculture crops, and then we use the waste part. So this kind of balance is needed, bearing in mind, of course, that we dump 40% in Sweden, at least 40% of our food production in waste. In many parts of the world, it's up to 50%, like in the United States. So that also we have to bear in mind. So we are talking all the time about degrowth, but why don't we limit the growth first and limit the waste, and then we talk about the degrowth? Because we might achieve the goals without being harsh on ourselves as well. And then, of course, addressing the potential for vulnerabilities, for pests and like decay, because it's not easy with this kind of use for all of those bio-based material. And the most importantly, I think, as a big challenge is the misconception. We still have a lot of stereotypes related to the use of bio-based material. But in order to overcome all those obstacles, we have to work together. So we have to put our expertise as layers on top of each other. And we need to work not only on a multidisciplinary way and not even on an interdisciplinary way, but we need to work on a transdisciplinary way. So that's the way forward, I think. And also we have to overcome certain barriers related to the increase of the awareness. So like here today, we are talking about it and more people are getting aware of this kind of material, their properties, their potential use, and also their downsides, because nothing is ideal. So everything has its pros and has its cons. So we just need to be aware of it and try to understand when and where and how to use this kind of material. And of course, we need policy support. So we need this kind of talks to also to be spread around and invite other policymakers and people in power in order for us to empower this kind of, the use of this kind of material. So a collaborative effort is definitely needed. And to be able to go beyond sustainability, and sustainability is in my opinion, is the most word that is overused, abused, and misused at the same time. So to go beyond it and move forward to more of a regenerative and also restorative way of thinking, and to achieve this kind of positive ecosystem impact, to at the end to reach this circular economical integration, which again it's an inspiration from an old default way of living. But the sky is the limit. So in order to achieve this future possibilities, we have no boundaries related to like being innovative or creative to make the best use of bio-based material construction. And for me, the future already started a couple of years ago on several levels. The first one related to education. As Johan kindly mentioned, we just started a new program in sustainable architecture and urban design. So it's a new bachelor program. So watch out for them after 1 year from now, because we started last year, so they will graduate next year. Actually, some of them already started to get some offers, because for them it's the default to know how to design and build with these kind of techniques and methods. So I'll just show you some examples. That's actually from Denmark, from Aalborg, with my master students. So they learn how to use clay, straw, reeds, seaweeds, and many more in a contemporary way. So they learn from the traditional techniques, and they try to find innovative solutions to make them complying with our contemporary needs, standards, and mandates. And they do all these kind of measures to make sure that they really comply with this kind of concepts. So we really understand the material, the performance, the behavior. We touch it, we smell it, we try to understand its performance and behavior, and we work also with the community, so it's always win-win. We learn and we share what we know from all these technical aspects. So it's not only it's not only university students, but also even kids at school. So that's an example from Bronshagen Lund, where we constructed this outdoor element with the school kids. So imagine that they made the design themselves, and also they built it themselves, of course under supervision. But the way they perceived it at the end, it was for them like a source of pride. Like they bring their parents, it's like, I put this ball here, this is mine. And I shared this piece with my friends and my colleagues at school, and it will stay here, and we will play here, and we will show it as a proof of concept. Similar to working also with workers. So this is from an experimental work with HSB, and we trained workers from PIAP on how to design and build with rammed earth and with Adobe Bricks. Is it a sign for me to stop talking, or is it? Yes. So so we need to bridge the gap again between what we do in research and what we do as architects, and also what we expect the contractors and investors to learn and to know how to implement them. And try also some crazy ideas like this cooling system, which hopefully will reduce 10 degrees of our overheating feeling in summertime. So it is just clay and reinforced bio-based material inside, and it's now ongoing testing. So hopefully by this summer it will be offered as an element, as a prototype, to be used as a retrofitting element, or also for new buildings as well. So imagine 10 degrees, zero energy cooling system, just by using clay and bio-based reinforcement inside. And many more of these test experiments, proof of concepts and trial, and doing some crazy vernacular applications, like using these two different natural materials, vas, reeds and jute. Actually, we were able to reduce 3.52 compared to other industrial material that was used. But actually, these very basic low-tech vernacular methods, it's possible to reduce the overheating by 3.5 degrees, for example. So imagine very small intervention can also cause a good change. And we shouldn't be afraid of trying and doing mistakes and trying again and learning from those mistakes. Even if people will say like, this is not possible, this is not feasible, this is crazy, this is not complying, but we have to start and we have to show evidence, and then by then the people will start to listen to us. Similar to this experimental work in Lund, also in Bronshagen. And then if I looked at this building now compared to 10 years before, when we tried to talk about using clay and straw, and people will say like, but we are in Sweden, we cannot do that. But yes, now it's possible to do that. So it takes time in order to do this kind of proof of concept and like test trials, so to show it as a showcase experimental work. It takes time, but bam, suddenly you get this opportunity to even invest more and do this kind of experimental work that will hopefully force the market to listen to our research outcome. So hopefully in 4 years, maybe the outcome of this research project will be displayed here in Forman Design Center, and we can celebrate the first completely biodegradable piece that we could use as a main construction material in our contemporary and future buildings. Until we celebrate that moment, it's 4 years from now, but I am sure it will pass very quickly as an eye blink. So until we do that, until we meet again with this kind of hopefully good achievements, I thank you so much for your listening.